Exponents. Student learning objectives. Define an exponent expression. Rules of exponents. Product rule, negative exponent rule, zero power rule. Define an exponential expression. An exponential expression is written in the form of b to the power of n, where b and n are not both zero. It's called an exponential expression. B is called the base, n is called the exponent. The exponent tells us the number of times the base is multiplied to itself. For example, b to the power of 3 is equal to b times b times b. Rules of exponent, product rule. B to the power of n times b to the power of m is equal to b to the power of n plus m. So the product rule states that if we are multiplying exponential expressions that have the same base, we keep the base and add the exponents. For example, 2 to the power of 3 times 2 to the power of 5. This here is equal to 2 to the power of 3 plus 5, which is equal to 2 to the power of 8. The product rule is used when the bases are the same. So for example, 2 to the power of 3 times 3 to the power of 5. In this case, we have 2 to the power of 3 is 2 times 2 times 2. And 3 to the power of 5 is 3 times 3 times 3 times 3 times 3, which is 5 times. And this is equal to 2, we multiplied it to itself 3 times, so 2 cubed, times 3, we multiplied it to itself 5 times, 3 to the 5th power. So you can see the results are the same. They remained the same here. Example, multiply 5x to the 7th power times 1 over 3 times x squared. This here is the same as 5 times x to the 7th power times 1 over 3 times x to the x squared. So this here, we can multiply the numbers 5 and 1/3. So we can write it as 5 over 1 times 1 over 3 times x to the power of 7, and then times x to the power of 2. So this here, we are using the property where we have, for example, a times b is the same as b times a. So when we multiply, the results are the same. So this is the commutative property. So we're using this to change the position of x to the 7th and 1/3. So for example, 3 times 4 is the same as 4 times 3. 3 times 4 is 12. 4 times 3 is 12. The result doesn't change, and we can do that. So now we have 5 times 1 is 5. 1 times 3 is 3. X to the 7th power times x to the 2nd power, they have the same base. So we add the exponents. So the end result here is equal to 5 over 3 times x to the power of 7 plus 2 is 9. X to the power of 9. Negative exponent rule. B to the power of -1 is equal to 1 over b to the power of n. Another one is 1 over b to the power of -n is equal to b to the power of n. Another exponent rule is a to the power of -n over b to the power of -m. And this here is equal to b to the power of m over a to the power of n. And another negative exponent rule is a over b, the whole thing to the power of -n. Then we take the reciprocal of the inside and it becomes b over a to the power of n. For example, 1 over b to the power of -3 is equal to b to the power of 3. So that is for this first row here. And for the second row here, this here is for the second row here. For the first row, we have a to the power of -5 is equal to 1 over a to the 5th power. And then for this row, we have an example here, 3 to the power of -9 over 5 to the power of -15. This is equal to 5 to the power of 15 over 3 to the power of 9. And an example for the last row here, we have 3 over 2, the whole thing to the power of -5 is equal to 2 over 3 to the power of 5. Notice here we took the reciprocal of the fraction inside the parentheses. Example, simplify. 3 to the power of -2 times x to the power of -5 over z squared times y to the power of -3. So this here is going to equal to, since 3 is to the power of -2, it goes in the denominator. And x to the power of -5 also goes in the denominator. So we have 3 squared. And then we have z squared. And now we bring x to the -5th power also in the denominator to make it, and so that it has a positive exponent, x to the 5th. And then in the denominator, we have y to the power of -3. To change that into a positive exponent, we take it to the numerator. So it becomes y to the power of 3. So we're not quite done. We have 3 squared. So we can evaluate this as 3 times 3, which is 9. So this is equal to y cubed over 9 z squared x to the power of 5. The 0 power rule. B to the power of 0 is equal to 1. So any number to the power of 0 is always 1, except we don't want b to be 0.